Okay, so just got done with chapter 5 on factoring, and now we're going to jump into chapter 6, which is on rational expressions and equations. Rational has that root word of ratio in there. Ratio, which is like a fraction. So when we talk about chapter 6 being rational expressions and equations, well, we're going to be dealing with fractions. But now our numerators and our denominators are going to be polynomials instead of just integers. So we have that to look forward to. Chapter 6 is going to be a fairly long chapter, but we're going to get a lot done here to get you better at mathematics. So here's what we're going to learn in chapter 6. We're going to add, subtract, multiply, divide, and simplify rational expressions. Again, rational expressions I want you to think of as fractions with polynomials. We're going to graph them, analyze them, and solve equations. We're going to divide polynomials by each other. You know, that's where rational expressions come from. We're going to use a form of division called synthetic division, and then we're going to solve applications, work problems, motion problems, and variation problems. So we got a full chapter for you. And it starts off with adding, subtracting, multiplying, and dividing. There's a good chance that with adding, subtracting, multiplying, and dividing all being today's lesson, that it may carry over into two different videos. So be prepared to watch two different videos tonight. So 6.1, multiplying and simplifying rational expressions. Do me a favor, let's just review a little bit before we get going. So take 2 or 3 minutes and see if you can do the warm-up problems. Multiply, factor, and then simplify this fraction equation over here. So take a few minutes and I'll do the same. See you in a couple. Okay, so here's the 3 problems. Number 1 should have been very straightforward, x squared plus 5x plus 6. Number 2, a very simple factoring problem of a quadratic into x plus 4 times x plus 3. And then number 3, let's talk about what I did here. First thing I did is I saw that 14 over 30 had a common factor of 2. 2 times 7, 2 times 15. So I reduced the 2's out and I reduced 14 over 30 to 7 over 15. Now I have 5/7 times this quantity, and instead of adding these together by getting like terms, I just decided to go ahead and distribute the 5/7. So this blue line here is distributing the 5/7. And now when you multiply fractions, it's really the easiest thing to do with fractions. You multiply across the top and you multiply across the bottom. So 5 times 7 over 7 times 15. And then I did the same thing over here. I ended with 5 times 7 over 7 times 5. And then I reduced top to bottom. 5 reduces with a 15. Take out a 5, I'm left with 1. Take out a 5, I'm left with 3. 7's reduced nicely. And here 5/7 times 7/5, those are reciprocals, so that gives me 1. I end up with 1/3 plus 1, and that equals 1 and 1/3, which written as an improper fraction is 4/3. So the warm-up problem for today, problems for today, you know, simple, simple, and then difficult, because fractions make things difficult, or as you guys like to think. But it's really not too bad, and I hope to teach you otherwise throughout the rest of this chapter. Today we're going to simplify fractions, multiply, and then simplify fractions, and then divide and simplify fractions. So you can see simplifying is going to be a key concept we focus on. Alright, well, let's get to it. So first objective, to simplify rational expressions, basically meaning reduce your fractions. Reduce your fractions. 3/6 can be reduced to, okay, 3 times 1 over 3 times 2, which is 3 over 3 times 1 over 2, and any number divided by itself is 1, so I end up with 1 times 1/2. 1 is the multiplicative identity, so multiply that times anything, you end up with the anything. So 3/6 equals 1/2, a very basic example of reducing your fraction. We're going to do the same thing with polynomials now. 3a cubed over a. This is a review. You should know that I can just subtract my exponents. A cubed over a to the first should give me a to the second. But technically this is 3 times a times a times a over a to the first. And because these are connected to each other by multiplication, I can reduce top to bottom, because a over a just means 1. And I'm left with 3a squared. So there's a very basic example of simplifying. Now notice here that 7x plus 21 over 7, some people might be tempted to reduce the 7 and the 7. But that's not allowed, because this 7 isn't a polynomial all by itself. It's a term, part of a term, 7x, which is part of a bigger binomial. So I can't reduce the 7 with the 7 or the 21 with the 7. If I wanted to reduce both of those with the 7, I could, but I prefer to teach it to you in the form of factoring and reducing instead. So what I do notice about the numerator here is 7x plus 21 is that it does have a GCF of 7, which then leaves me with the polynomial x plus 3. So I have 7, which is a monomial, times x plus 3, which is a binomial, divided by 7. Now this is the same thing as 7 over 7 times x plus 3 over 1, and 7 over 7 is 1, and then leaves me with just a final answer of x plus 3 over 1, which any number over 1 is just itself. So our final answer for problem number 2 is simply x plus 3 after we've simplified it. Alright, we got a couple more problems hiding down here. So do me a favor, take a minute, factor number 3. Factor the numerator, factor the denominator, and see if either of those factors can be reduced. I'll give you a couple seconds. Actually, take your time. Okay, so I hope I gave you enough time to press pause and then come back, and I don't remember if I told you to do number 4 or not, so if you didn't, here's how you should have done it, but if you did, you can go ahead and check your answer. Number 3, pretty straightforward. X plus 1's cancel out. You're left with x plus 4 over x plus 1. But notice the x's cannot reduce. Can't reduce them because they're not attached by multiplication. These are not factors. They are just a term in the binomial. Over here for number 4, I took out the GCF. Then I was left with a quadratic trinomial that was factorable in both the numerator and the denominator. I factored both of them. Realized that x plus 2 and x plus 2 were both reducible because those are both factors, and I'm left with 4 times the quantity x plus 1 over x plus 3. So far so good, I hope. Let's move on. Alright, you guys try these bunch of problems, 1, 2, 3, and 4, and come back and check in with me after about 10 minutes, which is what it should take you. Alright, I'll see you then. Okay, so let's see how we did. You can see here problem number 1, factored out the 4y and then reduced the 4y's, leaving me with the final answer of 5y plus 8. In problem number 2, I factored out the GCF of 2x from both the numerator and the denominator, leaving me with simply the quantity 3x plus 2 over the quantity x plus 2. Moving down here to problem number 3, factored the numerator, factored the denominator as the difference of two squares, and lo and behold, there's a common factor of y plus 1, leaving me with y plus 2 over y minus 1. And then lastly, a doozy of a problem here. First take out the GCF in the numerator and the GCF in the denominator, and that's what I'm left with right here. Now I look at this quadratic trinomial, and that turns out to be factorable to 2x minus 3y times x minus y. Look at this quadratic trinomial, and that is also factorable, and hey, look at that, another common factor that can be reduced top to bottom, leaving me with the final answer of 5 times the quantity 2x minus 3y over 7 times the quantity x plus 2y. I hope it's going alright so far, using our factoring skills to help reduce fractions. Let's keep it going. Alright, the next objective now is going to be quote-unquote multiply and simplify rational expressions, and we need to make sure that we know how to multiply fractions. Here's a fraction, here's a fraction. If I want to multiply those two fractions together, assuming b and d aren't 0 because you can't divide by 0, multiplying fractions is the easiest thing to do with fractions. Simply multiply the numerators together, a times c, divided by, multiply the denominators together, b times d. And that's it. There's your product of two fractions. So it gets a little bit more difficult when our polynomials are a bit more involved. And you can see here I have a trinomial times a binomial divided, and then a trinomial times a binomial. And when I take my first step, which is to quote-unquote multiply numerators and denominators, I'm not really interested in double distributing here, even though it says multiply. Instead, I just simply want to write it as one fraction. So I'll have x squared plus 6x plus 8 times x plus 3 over x squared plus 4x plus 3 over x plus 2. And now that I've written it as one fraction, now it's a little bit easier for me to do my reducing. Now it's not required to put them over one fraction to reduce top and bottom, but it does make it a little bit easier to see. I'm going to go ahead and switch to this purple color for the factoring the numerator and the denominator. So even though the directions did say multiply them together, we're really not multiplying them together because we have to factor them afterwards anyway. So we would just have to undo the multiplying and turn it into a factoring problem. Let me go ahead and factor the numerator. So that's going to give me a binomial times x plus 3, and then a binomial times x plus 2. So let's see, the x and x multiplies to 8, adds to 6, that's plus 4, that's plus 2. For the bottom one, x and x multiplies to 3 and adds to 4. Okay, so now I've done step 2, which is to factor the numerator and the denominator. And now on to step 3. We're going to simplify by removing factors of 1. X plus 2 divided by x plus 2, that's 1. X plus 3 divided by x plus 3, that's 1 also. And so therefore my final answer is going to be x plus 4 over x plus 1. So I multiplied these rational expressions together, but I didn't really multiply. I just wrote it together, factored, reduced, and then wrote my final answer that way. Let's see how we do. Here's an example problem. It's an involved example problem. Let's see how it goes. Here I have this fraction ab plus 7a squared over 6a plus 6b. Notice the GCF, something we'll want to factor out. Here I have this trinomial. I see a GCF of 3 here. And then I have 7a squared plus ab. Well, that looks very familiar. And notice that it's just the order is backwards. So these are actually the same expression as each other. That will be nice when I want to reduce. So I'm going to go ahead and rewrite the order of this. This is now 7a squared plus ab over 6 times a plus b times, let's take out a 3, and I'm left with a squared plus 2ab plus b squared over 7a squared plus ab. Let's go ahead now and follow those 3 steps. Step 1, write it as one fraction, quote unquote, multiply them together. Step 2, further factor all of these polynomials. And then step 3, reduce out the ones that are the same on the top as bottom, the ones that equal a value of 1. Put me on pause, take a few minutes, see how it goes. I'll meet you back here in a couple minutes. Okay, so let's see the work here. I did realize that there was a GCF in here. I took it out. You can see that down here. And I did the same thing for the 7a squared plus ab, a times 7a plus b. I didn't have to do that because they were the same as each other. I could have just reduced the whole thing. I just thought I would show the factoring as well. In addition, I took a squared plus 2ab plus b squared. That's a plus b times a plus b. And then here I had an a plus b that I had factored out previously. So now I reduce top to bottom. A divided by a, 7a plus b divided by 7a plus b, a plus b divided by a plus b. And here I have 3, and I thought this was a b originally, but it turns out it's a 6. So over here I had 3 times a plus b over 6, but the 3 and the 6 can be reduced into 1 over 2. So I left with 1 times a plus b on the top over 2 on the bottom. So final answer, a plus b divided by 2. Here's a couple problems for you to try, and put me on pause, take a few minutes, see how it goes, check your answers when you come back. Okay, so hopefully you had enough time and to look over both of them. See my work here on the green on number 1. X minus y squared is x minus y times x minus y. Down here in the bottom it's x plus y times x minus y as the difference of 2 squares. Reduce, 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 final answer. Here we have the sum of 2 cubes. That's SOAP, and you can see that work right there. Here this is the perfect square, so it's a minus b quantity squared. I ran out of room, which is why I chose to use this notation. Here's dots, and then this is not factorable, but it does turn out to be reducible with part of the SOAP above. So I reduced that, I reduced that, I reduced the a plus b with the a plus b, and I reduced the a minus b with one of the a minus b's in the numerator, leaving me with a simple answer of a minus b. Well, we're about done for this portion of it. Please check out part 2, which would be dividing. Alright, we'll see you then.